today. Today we hopefully have a fun video. Okay. Um, all my previous videos have been about modeling, whiteboarding, high level stuff. I unfortunately didn't get to record anything over the weekend. Yesterday's video was only 30 minutes because my iPad kept breaking. Hopefully it's working today. And almost even more so, I hope that I don't have to use it today. Hopefully it's working. But we did get something good out of yesterday. And yesterday is I decided what I'm going to do today is um, we're going to try to build a Groot language model. Um, and by that I mean is I want to own the entire um, process of from text, tokenization, training, loss, generation of a transformer architecture llama style language model. However, I also don't want to rent GPUs in order to do this. You know what I mean? Um, and I'm sort of thinking is okay, the architecture is you know what I mean? Your model configuration, D model, sequence length, et cetera, et cetera, et cetera. Those are your decision choices, you know? Is okay, well, so what if I did a really small model, a model so small that I could run on my CPU, and then instead of it generating real text, like coherent English sentences, is they spoke in the same way as Groot. It's like I am Groot, I am Groot, I am Groot, I am Groot. I have a feeling this would be like a 2 to 3 part series. So, um, because I imagine I can extend it where maybe initially all the text is just I am Groot, I am Groot, I am Groot. But maybe I try to show what's the word? Just some more qualitative stuff. You know what I mean? Like there's I am Groot all in lower caps and then all in lower caps. And then there's I am Groot all in caps. And then there's I am lowercase Groot in caps. You know what I mean? So I can sort of expand the vocab set and yeah, I don't know. It would probably still be nonsense. Um yeah, and it was how in terms of the text being generated, I don't know. Claude would be generating the text. Is I sort of have Claude generate a set of I am Groot speech where he is where in theory there's actually something sensible going on, but probably very unlikely we go that far. So first we have the whiteboard. Okay, let's see if this doesn't work. If this isn't synced up perfectly, I'm just gonna turn it off and we're just gonna go straight into Vault Chat. Let's see. I don't know, I feel like that's say hello. I think that's acceptable. I think that's acceptable. It's not seamless, but it can't be perfect. Okay. So what are we gonna do? I'm not hand typing this because then that would already take. It's already gonna take forever trying to vibe code this. Because I'm going to. Oh my goodness, I'm realizing this right now is I think I want to do this on a low enough level that I have to open up my terminal. That's brutal. Fortunately, if I'm opening my terminal, then I can use actual Claude code instead of Vault Chat. Vault Chat's really cool, but Claude code's also pretty good itself. Um, so let's see. Is I need data. What happened there? Okay. I need data. And then Claude. Claude will generate a synthetic data set. Then what? And we're doing my naive solution of how I would train a language model. Part of what I realized yesterday is significant reason of why we're vibe coding this is PyTorch. Is because it's not worth my time right now to study and learn PyTorch for the sake of this video. And I understand the forward pass, but I don't know how to code the backward pass and optimizer steps and all that kind of stuff. Particularly because you have to maintain the computation graph so that you can do gradient descent. That's some data structure stuff, memory, blah 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 blah. that's not something I can do sort of like from scratch in the same sense that I can with um how would I say, with the forward pass. You could hard code the gradients. Could you? I think you could hard code the gradients. You know what I mean? It's like you could have like a particular model. So it's not that it's impossible. It's just I don't think it was necessarily worth it. You know? Because at the end of the day, how do I say? Even something like Torch Titan, just anyone like like writing a model, it's yeah, you're not doing the back prop by hand. I don't know. Is a decision I made for now. What I was saying prior is nothing's hard and fast. You know, these things are still in the air. So we have PyTorch. Okay, Claude's gonna generate a synthetic data set for us. We're going to do first. We want to tokenize, and then importantly, I'm vibe coding this. So like, but like, I'm vibe coding on a function level. That's like the important distinction. Is like I have to decide this sort of like inputs and outputs and like how it runs and how it works. Is like we're gonna run it and then it's gonna break and then again we're going to have to find out along the way. I don't know what's gonna happen. We're gonna tokenize and then this is gonna give me vocab. And then how do I say? There's already a thing that I'm missing is like they use a how do I say? I don't know. Data dot bin is like they actually like turn their or like it's well within scope to take your data set and like turn it into like how do I say? There's a word for it, and I don't know the word. It's not coming. It's not immediately coming to me. It's like there's like actually the starts with a C or something, and it's your data set, but in your token ID space. You know, and then that's what your data loader is going to use. So, let's see, token. I'm going to do vocab. I'm going to call it cast. Let's see, cast. Let's just do this. And then I'll get something like the data bin. Um, then I want to use a data loader. But what's the order in which I'm going to build this? Is how do I say? Okay, data tokenize. Data loader is supposed to take how do I say? I don't know. I give a sequence length and I give a batch size. And what else? And it sort of has to like maintain. I don't know if that's how you spell maintain. Oops. It needs to recall, you know what I mean, the state of the data points that we've actually pulled from. So like I could load repeatedly and not reuse observations. So that's fine. Data loader, and then there's the model. And then this is where PyTorch like really comes in. Is like how do I build the model in PyTorch? I don't know. Um we have we have a data point, okay. Rope. Yeah, I don't even know. And yeah, so this is like so like rope. Nope. What is it? Rope. Um, norm, normalize, attention, FFN. You know, norm, add norm, blah 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 blah. Cast out. You know, that's just like the model. And so like, how do I say? This what part is inside of the transformer? Like what part is like being stacked? rope is outside of the transformer. Transformer is a tension in FFN. So like I think I'll do by N. You know what I mean? I'll do N transformers. Maybe. I should be able to. Um, and then what? Then it's the output, and then at some point, like loss dot backward. You know what I mean? Or is it loss dot back? I don't know. Yeah, and so this is our extremely high level. I think we're at a point where let's split screen this with Vault Chat. I'll talk to David, Tony, Alfred about um about this. Um I'll have it like sort of like scope it out with me and then we'll go for it. So if I go for it fully blindly, again, yeah, we're following my discretion, you know? Because AI could totally just like give me sufficient information to cheat and even like after like seeing the information or whatever, I'm going to choose to do it in, you know, oh the way that I think is, I don't know, best. Okay. So if you want to look at this, that's not really useful. I might choose a different way to split everything. Computer seems to be taking its time. Okay. So we'll split and then, okay, this is a little bit wide, I guess. This easily could take a very long time. So let's see. What did I call it? I called it GLM. We're doing a Groot language model. Okay. And do I have whisper flow? Whisper flow would be very, very, very useful right now. I don't have whisper flow right now. No, whisper flow would be so fantastically useful right now. Let's see. Whisper. Really? Am I spelling it wrong? I lost whisper flow. I didn't delete it, did I? Wait, where'd it go? Oh, I was spelling it wrong. Okay, perfect. Okay, so turn back on whisper flow, and then I'm going to sort of like speak this drawing out loud, and then I'll iterate on that, and then then we'll talk to Tony, Bruce, David. Let's see. Why is my computer so slow? Flow processing. Perfect. Hopefully all I need to do transcript failed to load. Yeah, that's okay. Don't worry about it. Hello, how are you? Okay, perfect. So, hello, this is the beginning of the design doc for a project that I'm working on. We're going to call it GLM, which stands for Groot Language Model. The overarching goal is to build a very small, technically language model, but in the same structure as sort of like Llama 3, maybe without the group create attention. Maybe, I don't know, I'm not entirely sure, but I want to do it in like in PyTorch, and I understand the forward pass and like the higher level design of a large language model, but I've never coded one before, and I'm not extremely certain with working in PyTorch or backprop, so I need a little bit of help with that. Starting off with what I'm envisioning is that we're going to generate a synthetic data set, and then Claude is going to write a whole bunch of stuff of something like I am Groot, I am Groot, I am Groot, and then we're going to enter that into, we're going to have to build a tokenizer, which will then give us our vocab data set. And then we can sort of take that data set and then pass it back again, or take that vocab indice. We can take our learned tokenization and sort of cast that onto our original data set that's in natural language. And then we can sort of turn our sentences into, um, you know, things in like token index space. And then that's the first form of our raw data set. Then we need to have the data loader, which will give something like the sequence length and the batch size that we're expecting, and then that'll be returned. But like, I think the data loader needs to be able to manage or like maintain this idea of like what data has been pulled from it. You know what I mean? Of what data, once it gives us a sequence length and batch length, if I want to pull the next piece of information, it needs to sort of like maintain knowledge of what it can and can't sample from. Um, then from there, we need to do rope, normalization. I think I would like to have like a transformer block class or something, where we can do the attention normalizing FFN, all that kind of stuff. And then I'm sort of assuming is that we just do, we go all the way, we finish the language model, we perform loss, and as far as my understanding for PyTorch is you just sort of do back or like loss dot backward or something. And then how do I say this? And then you continue to iterate. So we also sort of need to like formalize like the training section, I guess. Hopefully that's big. Maybe it's not. I am group. I am group. And this is where, let's see. This is where Vault Chat glitches. Beautiful edits, seamless, amazing. Um, let's see. Okay, so now we can talk to the assistant, and I'll full screen this, and that means you need to go away.
I hear you. I will step back and let you work. Just say the
No,
word when
sorry.
you want to jump back in.
Hi Tony, how are
No
you?
worries at
I've
all.
missed you. Um, welcome back. Is check out this GLM doc. It's sort of this um how do I say? It's this idea for a project that I'm working on, and I don't have all of the details out. And I think you can see the direction that I'm going, and I'm wondering if you can sort of help me give this a bit more structure before we start actually building code and stuff.
It is great to be back. I am doing well, and I am excited to dive into this with you. Looking at your GLM design doc, the core idea is super clean. You want to build a small llama-style model from scratch in PyTorch, starting with a synthetic I am Groot dataset, tokenizing it, building a custom data loader, setting up the transformer blocks, and training it with backprop. To give this some solid structure before we write code, we should map out the exact contracts and boundaries between these components. For example, the first boundary is your tokenizer. Its contract is simple. It takes raw text and turns it into a sequence of integer token IDs. Do you want to start by defining the exact inputs and outputs for that tokenizer? Or would you rather look at how the data loader is going to manage sampling those IDs?
Um, so because I'm new to PyTorch, I think actually give me a moment. So I actually am curious right now. Is I would like to ask for a draft, you know, is I would like for it to propose something for me. It's like, I want it to sort of already tell me what I'm missing. I don't think that's what I actually want. I think I should try to fill as much as I can, and then when it fails is when I'll ask for help. So let's do that. So I'm back. I how do I say? I would like for you to sort of let's do this sort of like an interview style. Is I'm going to express my ideas and you can sort of like ask me questions about these contracts and things, and you can push back and point out to me when I've missed something. Um, and we can go section by section. So yeah, first thing is that Claude is going to generate the data set. That's fine. That'll be a .txt file. Okay. Then you're correct. We need to tokenize it. Um, the tokenizer, what does it take in? It's going to take in the text file. And what is it going to spit out? It's going to spit out the vocabulary set. So it's going to spit out the tokens and their IDs. And then I'm not sure how it's going to work, but say, if we're, say the tokenizer is a file, another function in this file would have to be the ability to take the text and then apply the tokens so that the input can then be cast from the .txt. I'm not sure of what file type we would change it to, but like, you know, we would we would then turn it into its integer form. So there's sort of like two stages. Is first we need to learn the token space, and then we need to um, cast our natural language into that token space. Um, that's what I have for the tokenizer. Hello?
I am right here. Let us dive straight into the tokenizer contract. You nailed the two distinct phases. First, learning the vocabulary from the raw text, and second, encoding that text into integer token IDs. To push on this design, what happens when you want to run inference later and turn the model's predicted integer IDs back into readable text? What is the exact input and output of that reverse operation? And does your current tokenizer file structure support it?
Yeah, it would be completely fine because how do I say? Because we created the mapping. The mapping works in both directions. It's one to one of a token to its ID. So our large language model will spit out things in token IDs, but those will can immediately be used in the reverse map into vocabulary, into like sort of like English tokens, which can just be stacked together in the standard sequence form that's native to the model.
That makes complete sense. A two-way mapping, integer to string, and string to integer, handles both encoding and decoding perfectly. Let us push on the boundary of this contract. If the tokenizer's job is to turn raw text into a sequence of integer IDs, what does it do when it encounters a character or a word that was not in the synthetic training dataset? How should the tokenizer handle that? And what does it mean for your vocabulary mapping?
That's an interesting thing that you're proposing, but we're not going to address that today. Mind you that, I want to keep this like a well-scoped project that in an ideal world that we could almost finish it tonight. So we don't need to worry about that edge case. We have the tokenizer. Keep in mind the sort of like design choices of what we're working on so far, and then let's continue. So I believe that we have the tokenizer. What's next? And let me give you a bit of a note is I only really want you to push back if I'm missing something critical, not to cover all the edge cases. You know what I mean? Is like, oh, I funnily missed something like what about adding and normalizing? across layers, how am I going to handle numerical precision? If that, you know what I mean? Is like I made a design choice that like you realize will result in a numerical precision issue. That's when I want you to push back and tell me, oh, well, you need to normalize across D model space before you do this kind of stuff or something. You know what I mean? Let's keep going.
Got it. No unnecessary edge cases, just the load-bearing structural gaps. That will break the math or the training loop. Let us move to the data loader. Then you mentioned the data loader needs to return batches of a specific sequence length and batch size and keep track of what it has sampled here is the structural pushback. For an autoregressive language model to actually calculate loss and learn the data loader cannot just return one sequence of tokens per batch element. It must return two distinct tensors for every batch. The inputs and the targets, if your sequence length is 4 in a single sequence, is the tokens. 1, 2, 3, 4, 5. What are the exact inputs and targets the data loader must provide so the model can actually
Wait,
calculate causal loss?
wait, I'm quite confused. I'm imagining that the data loader is like effectively my sampler from my data set. So it's going to give me the sample is oh, and maybe these are the two sensors that you're talking about that I didn't mention, is that it's going to give me the input and the output. You know what I mean? Is it's going to give me a shifted by one in the sequence, one tensor of the input and then another tensor of the output, but they're both actually matrices if our requested batch size is 1 because they're going to be sequence. No, they're actually, how do I say? They should be matrices at best. It would be two matrices because they have a dimension of sequence length by batch size. We have yet to explode to demodel or anything like that. So technically it's a two-dimensional tensor, but I agree that I need two two-dimensional tensors, one x and one y. Hello?
You have it exactly right. It is two matrices, both of dimension batch size by sequence length, where the target matrix is shifted by one token to the right. That shift is what allows the model to learn to predict the next token at every single position in the sequence simultaneously. Now let us look at the next step in your design. Rope normalization in the transformer block. Before we even get to the attention math, those token IDs from the data loader are just integers. We cannot pass integers into neural network layers. What is the very first layer that must sit between your data loader's integer matrices and your transformer blocks? And what does it do to the dimensions of your data?
Yeah, so we need the linear mapping, and this is part of sort of like a confusion that like this is something that, I don't know the solution for, but I need a solution for is like, oh, well, it's the linear mapping. Is we're going to go from IDs and we're going to embed exactly all of our tokens into their D model space. So like if you can imagine that, oh, we have a model, I would sort of like to propose, I would like that we designed our code well such that I can change the model's architecture with just like a config file. Is like D model is a configuration choice of the model, and we're going to linearly map to those weights. But importantly, they're weights. And because I'm not familiar with PyTorch, you know, I don't know how we're going to do this and everything stays connected. That's something I'm going to have after we've built this. I'm going to review that. But yes, is the first thing we need is weights to do a linear mapping, and then it's going to change from batch size to batch size sequence length matrix to a batch size sequence length D model tensor. Hello?
You are spot on. That layer is the embedding layer, which is indeed a lookup table of weights that maps each token ID to a vector of size D model. In PyTorch, this is represented by the n.embedding class. It manages those weights automatically, and when you pass in your batch size by sequence length matrix, It outputs the three-dimensional tensor of batch size, sequence length, and D model. Now here is the load-bearing structural question for the transformer block. Once you have this three-dimensional tensor, you want to apply attention. In your design doc, you mention ropey or rotary position embeddings. Does rope happen before the attention layer as a separate step, or is it applied inside the attention layer itself? What does it actually modify?
Rope is separate from attention. Attention belongs inside of the transformer. So we can perform rope one time, and then because the we can perform rope one time and then repeat transformer blocks. Rope is just embedding. It's the first staging of imbuing new information into the tokens. It's right now. There's no notion of sequence. There's no notion of order. So performing rope is just going to be, we're not going to change the shape of our data, but we're going to inject information into it, which is, in terms of like math form, I believe it's technically a multiplication with a rotation matrix, but it's a bit of a interestingly shaped matrix.
This is a massive load-bearing design point where we need to push back, because doing rope once before the transformer blocks will actually break the attention mechanism. While traditional positional embeddings, like absolute learned embeddings, are added to the token vectors once at the very beginning, rotary position embeddings, or rope, are different. Rope is designed to rotate the query and key vectors specifically. If you apply rope to the raw embeddings before the transformer blocks, that rotation gets mixed up and destroyed by the linear projections that create the queries, keys, and values inside every single attention layer. To make rope work, you must apply the rotation inside the attention block, specifically after you project your hidden states into queries and keys. But
So
before you
very interesting. This is new information for me. So rope is only performed on Q and K.
Yes, exactly. Rope is applied only to the query and key vectors and never to the value vectors. By rotating the queries and keys, the dot product between them naturally captures the relative distance between tokens. If you rotated the values, or if you rotated the embeddings before the linear projections, you would lose this mathematical property entirely. This means your attention block needs to take in the hidden states, project them to queries, keys, and values, apply the rotary math to Q and K, and then perform the scaled dot product attention. Does that distinction make sense? And do you
Yes,
see?
yes, it does make sense. I see it now. Thank you. So yes, that's very important. And once again, how would I say this? Is okay. Well, then if rope is inside of our transformer block, then it's just embeddings transformer, then LM head.
Yes, that is the exact macro architecture. You start with the
Okay.
embedding layer,
So then
then you
in
pass
terms
the
of our designing is like, okay, so then we just need to define like the transformer class. Um, so we'll do the transformer class, we'll do like, the fancy PyTorch stuff, and then we'll have like our actual model class, which is defined by like the configuration. And then after we've done all of that, then what? How do we get to loss? Am I jumping ahead?
You are not jumping ahead at all. This is the perfect next step. To get to loss, your model needs to output predictions. The final transformer block outputs a tensor of shape batch size, sequence length, and D model. To turn this back into token predictions, you pass it through that LM head you mentioned, which is a linear layer that projects D model back to your vocabulary size. This gives you logits of shape batch size, sequence length, and vocab size. Now here is the load-bearing question for the training loop. To calculate the loss, you have your logits matrix and your target matrix from the data loader. PyTorch has a standard loss function for this called cross-entropy loss. But before you pass them in, do you need to do anything to the shapes of your logits and targets? Or can you pass them in exactly as they are?
I think you're referring to the logits as like their um fixed, their, how do I say? I don't know, their non-activated form. It's not an activation, but what you're hinting at is that we need to do softmax. We need to do softmax and turn softmax across vocab space for every single sequence, which is, how do I say? Across vocab space for every single. Oh wait, no, in both in yeah, in both senses for every single token in the sequence, for every single data point. Is there's how do I say? There's a predicted next token for every single word in the sequence, and that's what we're predicting over vocab space, but we want it to be distribution. So I think what you're pointing at is softmax. Thank you.
Actually, this is a classic PyTorch trap that would have caused a major bug. In PyTorch, n-dot cross-entropy loss expects raw, unnormalized logits. It actually performs the softmax internally in a highly numerically stable way. If you manually apply softmax first and then pass it to PyTorch's cross-entropy loss, you will be applying softmax twice, which ruins the gradients and breaks training, so you keep the logits unactivated. The actual shape issue is that PyTorch's loss function expects a two-dimensional input for the predictions and a one-dimensional input for the targets. To solve this, you have to flatten your batch size and sequence length dimensions together. You flatten your logits to a matrix of size batch time sequence by vocab size, and your targets to a single vector of size batch time sequence. Once you have that loss, you run backprop. Since you mentioned you are new to PyTorch, do you know the three standard load-bearing lines of code you must run in the training loop to actually update the weights once you have the loss?
No, I know Torch no grad, I think, but then no, that would be it.
That is completely fine. This is the core engine of PyTorch, and it is incredibly simple once you see it. To update the weights, you need an optimizer, like Atom W, which you set up before the loop. Then for every training step, you run these three exact lines. First, optimizer, zero grad. This clears out the old gradients from the previous step so they do not accumulate. Second, loss, backward. This is the magic line. It calculates the gradients for every weight in your model using backpropagation. Third, optimizer.step. This actually updates the weights of your model using those calculated gradients. With those three lines, your model is officially training. How does that feel as a complete end-to-end mental map of the system? Do you feel ready to start structuring this into actual files?
Yeah, yeah. So it sounds like we've walked through everything end to end. Um, I think the only thing we're missing is like I think for the sake of fun is I would also like to have a generate file, but yeah, is sort of in line with what we've been discussing. Can you add to the bottom of this document what it is that we would build? Do we have all the sufficient information? Hello.
Yes, we have covered the full pipeline. Let me summarize the key components you will build. 1. Tokenizer, a script to learn the vocabulary from your dataset and decode text from token IDs. 2. Data loader, a PyTorch data loader that returns input and target tensors for training. 3. Embedding layer, maps token IDs to D-model vectors. 4. Transformer block, includes attention with rope applied to queries and keys. And feed forward layers. 5. Model class, combines the embedding, multiple transformer blocks, and an LM head to output logits. 6. Training, loop, handles data loading, forward pass, loss calculation, and weight updates. 7. Generate script, uses the trained model to generate text from a given prompt. With these components, you have a complete end-to-end language model setup. Ready to start coding?
I would like for you to give me a bit more details inside. I want you to edit my glm.md. I want you to give me the file folder structure, and then I want you to tell me what functions and classes are going to exist in each of them, and then I want you to sort of like just describe what the end-to-end flow is in terms of like the scripts that will actually be written. Hello? Hello?
Okay, I will add a detailed structure to your glm.md file, outlining the file organization, the key classes and functions within each, and the end-to-end script flow. This will serve as a blueprint for your project.
Okay. So I don't remember any of the conversation. Did it just disappear on its own? Let's see. Oh, unfortunately, you can't see my text box inside of all chat. So sorry. Um, so I'm just asking in chat. Same thing. I'm pretty sure it'll have all the information. So I will add the detailed. Perfect. Including the two corrections. Per Perfect. So yeah, that is nice. You know what I mean? It's like that type of thing is like, especially like that logits thing is like, oh, okay, PyTorch expects a different shape. But like or like, I need to collapse my batch size by sequence length because of the shape that like PyTorch expects. That's not a thing that I want to like that's so not what I want to like I don't want to like learn that before and then try to do something. It's just like, Claude knows. Let's find out after. Okay. Build blueprint. That was a lot more than I'm expecting. Let's see. Corpus is the name. Let's see. So Claude generated AM Groot. Corpus writer. I was about to say this is to generate the synthetic data. That's different than that. Yeah. Config.py, the master config in one place. Change the whole model and training. That's interesting. Tokenizer, data set. So this is the data loader. I would call that data loader, not dataset.py. Model, train, generate, checkpoints. Ooh. What lives in each one? End-to-end flow is generate it. This drives everything. Python train, Python generate. The one unbroken data line is, let's say, well, you guys can't see this. The one unbroken data line, text IDs, batch, logits, cross into be logged, ingredients, update, loot. The inference is prompt, logits, sample, append, loot. Okay, so we're only going to input things in our vocab space. So there's like a few small fixes. So two small fixes is we're obviously going to need sort of like data. How do I say? If I want to do like this sort of prompt thing, is how do I say? I would like to be able to talk to the agent inside of my terminal. So that might be a functionality that we're going to need in the downstream generate.py. I also would rather name the dataset.py data loader.py, and then also the data generation generate.py. I'm not expecting to have an API key for Claude. I'm expecting for you to just like actually like this agent right now can write the data set for me, so we don't need a generate.py in there. So those are the few small fixes. I think I would just have it build the whole thing. You know what I mean? It's like, okay, we're fixing it. We got data loader. We have generate.py. Is like you'll generate it already. You want to call? Do you want to call data loader.py? Yeah. I think guessing. Yeah, I said data loader. Yeah. The old generate removed entirely. Yeah. For the corpus sampler file, do you want it called dataloader.py? I still want the data folder, and yeah, that's the name I want. Okay, so this feels super lean. You know what I mean? Redevelop. Okay, cool. Oh, and let's see, in training, I would like terminal logs and how to say matplotlib exports of loss and epoch stuff. Let's see. Terminal logs, matplotlib, epoch stuff. I'm only correcting this for you guys. Everything. Do we have everything we need for you to build this in one go? And that would sort of be it, you know what I mean? Like, I'd have Claude build it, and then I'd run it in terminal. And I don't know. I actually don't know about from there. I have to read it, you know what I mean? This would be like part one is like, okay, so we have Groot. And then next video is like, okay, let's like look into it. And then now we're like four more conditions. You know, we're one step closer to like reading the coconut code. No, I want BPE. BPE, and I just want to know you can do it in pass. Do you have what you need? Then just okay. So yeah, I want BPE. I just want to know if we can do it in one pass, no mission. Yes, it can do it in one pass. Has everything I need, perfect. Okay, I said it didn't have to do it yet, but it looks like it's going to go for it. Um, so you have what you need to understand. You can build and test end to end, and then just point me to what I need to do in terminal in order to try it out. Yeah. So I think, how do I say? Let's take a pause. Hopefully, hopefully Claude locks in and is successful in what it's doing right now. Um, how do I feel about this? I feel like I was involved in that, but I am still abstracted from the code. We got information, we learned validation of like what I understand and stuff, but there's things for me to inspect. There's the loss for me to inspect. You know, there may be other small things like I don't know if it did group query attention or standard attention or like how many transformer blocks it's doing. Um, so all of those things I'm going to need to look at in greater detail, but because I was there in the conversation of this all being designed and built, looking at the code should not be as fearful. Is like, I don't want to make this a giant series or anything. So hopefully I could do like, it's 7 files. Hopefully I could do 3 files in one video. You know what I mean? One video is like is an hour. So like 20 minutes with each file. And that would be two more videos after this one. I don't know, this might be like a 4-part series or something. I'm unsure. But hopefully, you know, if it runs and if I could talk to Groot in terminal, that'd be so cool, you know? Yeah, and then I'd be happy to call it here. It's like this is like the first thing, this is it, it's built, and then we start inspecting it next video. And then yes, and then it means I would be leaving in time to how do I say? I can still get pot belly. before they close. There's a Potbelly by Lake. Oh, you don't know where I am. You don't know where I am. Um, Path mismatch, yeah. It could take its time doing that. So let's see. So corpus is the word that started with a C. Hopefully you guys like my thumbnail. That's still being debated. I could do it in like Canva. I kind of what's it called? The current version, as far as I know, is handwritten. Um, I was very happy my iPad didn't shut down today. I don't think it was seamless, but it didn't shut down, so that's good. Um, I hope this finishes. I really need this to finish. Oh, and then if this works, cool. I can finally. When was the last time I used the terminal button in Vault Chat? You know. Oh my goodness. I'm never at my apartment enough. This button pops out chat, so I can do split screen. Like one monitor is just the chat and one monitor is the actual app. But I'm not using like a dual monitor setup with Vault Chat enough that's significant. And then this is that's the terminal button. And yeah, it should default. Oh yeah, Control J is the command. Um, it should just open us into the root. And how to say? I'm almost a little bit worried that. Oh, okay. Oh, that's so cool. There's a GLM folder. Data. Oh, that's so cool. No, because we're involved in this. This is optimal vibe coding. Let's see. Corpus.txt. Okay, so it already went for the doing the various forms of text. I am Groot, I am Groot, we are Groot, I am Groot, I am Groot, I am Groot, I am Groot, we are Groot, I am Groot. So hopefully, ideally, is that we get coherent Groot statements. You know what I mean? Model validated, the number that matters, initial loss versus loss went down a little bit, or that's just one. No way we have a million parameter model. Where we are, what's left? Why are we not done? I did not finish in one pass. I ran out of context budget. Just send another message. What? Okay, finish. Okay, so that's our corpus. Build status is, I don't know, we're mostly done. Config. Let's see, config.py. That was sort of interesting. So this is a corpus, this is our tokenizer. Tokenizer is a JSON. Okay, it's learned. It's learned. So it's a one-to-one. But then where did it go? It hasn't been generated. Okay. Checkpoints. We have yet to have a checkpoints file. Folder. Loss. Okay, these are our map plots. Perfect. How are we going to get a vocab size of 512? That's the motive of the tokenizer. How's that even possible? Yeah, that's kind of part of the issue. Like, how to say it? Rope theta, model architecture, D model, and laters. This is a huge model though. Training, batch size, sequence length. There's no way. Try it myself. There's absolutely zero shot. There's zero shot. It's a million parameters. Wait, it trained the model already? Guys, there's no way. There's no way. What was it telling me to do? Let's check. Let's do control shift V here. Okay. It's just train and generate. Well, you're not in the path. let's see, CLS, CD, GLM, CD, no, Python. What is it? Train.py. This will train the model. I guess not. Did I miss something? Train.py. GLM. Looks like you didn't finish or really verify. I think I just got lied to. Okay, so it didn't do anything. Yeah, it's like, how do I say? That loss didn't make sense because this configuration doesn't make sense. It's like, how are we going to get to 1,000,000 parameters and like our corpus is like 20 lines? Now writing train, the loop. Okay, that sucks. I was excited because that was insane. If that was like, if the claims were correct. Aw, man. Ding, 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 ding. Atom, we have learning rate, batch size, sequence length, max steps, learning rate, weight decay. That's got to be a atom hyperparameter. Grad clip got to be an atom thing. Warm up got to be atom. Log every, sure, whatever. Eval every. That's just steps. Seed for our random initialization of weights. Post init. Oh, that's the whole thing. Interesting. So it's a data class. I need to lock in on data classes. Apparently, that's a very normal thing in Python. Good, the error is a real bug. The tokenizer is over merging the tiny. Exactly. With vocab size, exactly. You're trying to do way too big of a vocab. Um, Perfect. So glad that that's failing. Hopefully it'll iterate on that. When I reload this, hopefully, okay, good. Is merges. That's strange to me. That's not what I expect in the tokenizer.json. I expect I expected the mapping. You know what I mean? I expected to see like the actual chunk. Because what are these referencing? Their index, like the character index. Wow. I feel like that's a lot to do. The architecture files are solid and self-tested, but it does not train yet, and I won't say otherwise until it shows files. Send continue, and I'll fix the tokenizer bug. Yes. Oh my goodness. Who would have thought? Who would have thought this would be so difficult? And, I guess I'm sort of just like yapping now because we're in idle time. Is I I try to go back and forth of like, I wish I just like tossed like the actual there's like a custom harness behind Vault Chat, custom harness. Um and like, when I'm building it, I sort of like have to have like so many things like in my mind of like, you know, Vault Chat is like limited in the scope of what I can imagine. Um it's like all of like they're like really nice features of like a harness outside of the fact of like I say like go look up the state of the art. I do that like quite frequently. Um it doesn't fully get it. So there's things missing, and how do I say, like the Claude, is it the Claude Code SDK or is it the Claude Agent SDK? I don't know, but like the packaged thing from Anthropic would be better than what I'm using. Um, but it would also stop me from using OpenRouter. Even though I'm actually using 4.8, I'm not even using 5 right now. Config is clean. There's no way that that's all you had to change. Is cut the vocab in half. Did you even do It's not even fully in half. Good. Trained up high. Let me update. I don't like this. And it's saying resume point. I need to just delete my North Star. It's doing too much thinking about my resume. Let's see. Good. Are we done? Guys. Or is this isn't resume, this is resume. I'm gonna drop Opus 4.8 for how do I say it? For an OpenAI model. Let's see. You want me to do it? You do it, please. Don't stop until and ready for me. Maybe this isn't optimal vibe coding. Fable 5? No, let's just do, how do I say? OpenAI. Let's do GPT dash 5.6. There's no 5.6. I only have 5.5. That doesn't make any sense. I need to refresh my models. Hopefully this doesn't break anything. Oh goodness. Ball chat, you can't break on me. You can't do this to me. Let's see. GPT 5.6. Nice. What's it called? Soul is the big one. So Luna sounds like the moon. Terra. Guys, I don't even know. Let's just do 5. Okay. We're gonna do GPT 5. Hopefully it's smart. I have no credits remaining. Fantastic. That's because you're trying to use, yeah, 5.5 Pro. That's because it's trying to use my actual OpenAI API key instead of OpenRouter. What's the context limit? Oh my goodness. And we're back we're back to Anthropic. I don't know if I have, this is Fable 5 on actual Anthropic API. And it's throwing, oh my goodness. Anthropic. Okay, Volchat is built to work with Opus 4.8. It's like, I was putting, Opus 4.8 was like, the best out there when I was, the last time I was actually tweaking Volchat. So I guess we can't change models very seamlessly. I don't think it's going to work either. How do I say? I expect this to fail. Like the corpus is too small for the scale of the model that it's attempting to build. I said I wanted a tiny language model. You have a generate.py? Where is it? I don't see it. Nice. Load model, respond. This is all, yeah. This is all just that I can do inside of, oh, that's so cool. Prompt, you. But can't even handle a prompt. No, okay, no, it's input, it's original Python input. That's cool. I am Groot. Groot. Now let me run the actual pipeline, the whole point. Yeah, thank you. Let's see. Reload. There should be a new, in an ideal world, there's a new file path. What just got added? Wait, I expected a new folder. Make corpus. Each line. Okay, you made a lot. Yeah, it wasn't big enough. There you go. You had handwritten it before. So now we have a far larger corpus, of internet to train on. Perfect. It's random. That's good. Tokenizer. I'm still not very confident in that. I don't know what this is for. What kind of helper is this? Diag? Feel like that's like, I don't know, diagnose an issue? I don't know why we have that. I hope that goes away. Same thing with this. Build status. I don't want that. That's just LLM bloat. Config, data loader, generate model, pi, tokenizer, train. Yeah. Those are all that I'm comfortable with. Okay, the overfit gate pass. Learning works, gradient flow, loss. Perfect. Where are the checkpoints? That's the thing I'm missing. It better pop up right here. Where are the checkpoints? They're not in PyCache. Oh, files present checkpoints doesn't exist yet. They lie to me. Hmm. Okay. This is taking a while. Oh, okay. I'm not gonna be able to get food. That's unfortunate. I wonder how you guys feel sort of like on YouTube. And I don't know if I've been talking. I wonder if there's actually just been like 2 minutes of like silence or if I was just talking. I don't remember. Because I could be talking in my head and I don't know, it's equivalent to me. Um, yeah, I wonder how boring this is for you guys. Watching me like, I don't know. I would never watch like a vibe code. Like what's going on? Ask a better prompt or something, dude. I don't know. But I want this done. And I'm going to finish this. At least really try to, you know what I mean? It's like as long as it doesn't like jeopardize, as long as it doesn't result in me leaving at 11:30, you know what I mean? Which would literally be a whole another hour. So this video could be quite long. Um, but yeah, I would like for this to be finished. And then yeah, whatever. I think the ironic thing is the scale of this is small enough that like a competent engineer potentially could have done this in ooh, all of this in 2 hours by hand with no syntax errors. Nah, you got to be real deal for that. That's crazy. I don't even know if that's like humanly feasible. Just like any, I don't know, practical engineer. Oh no, you need to get plugged in. Let's see. Okay, perfect. Charging. It claims to be running. The overfit was the overfit worked fine. And I'm not able to ask what the expected runtime is. And there's no formal mission, so it's not like, how do I say it? Because missions don't work right now. I haven't worked in a couple of weeks now. Good checkpoint. This isn't good. No good. Not good. How's this? This is 3 minutes. Oh wait, I can see the whole command. Full train, python train.py. Hmm. But then yeah, how's that? Is like, oh, it's something I can train on like my computer. How long is it supposed to take? How many parameters? There's no way. I would interrupt it. Stopped. 2 questions. Number. Okay. Yeah, I have a few questions. It's like, what's the expected runtime? Because, like, in theory, we're waiting that right now. And then also, how do I say? No worries. Um, what's the expected runtime? How many parameters do we have? And was it running in the background? Where did it go? Where did my message go? I would like to, how do I say? What just happened? Where's it? Where are these going? Hello? I send a message and it just poofs. Okay. Terminal, come back. I should be able to watch it. There should be logs. And now, now is the time to be a frustrated vibe coder. Maybe I open actual Cloud Code and yeah, what's with, how do I say it? Why are we trying a million parameter model? Okay, step 0. Let's see how long it takes to get to step 1. No. Or we can have that in the corner, sure. But practically speaking is like I'm not training a million parameter model on CPU. Like, get real. Really? That was a step? That was step 50. And our loss went down? Our loss did go down. Are we going to watch this? Are we going to watch this all the way through? Oh, there's no timestamps? Let's see. This could take a while. You want to sit through. How do I say? Guys, I don't edit these videos. I'm not gonna cut ahead. You should skip ahead in this video if it turns out that I decide to actually wait all of this. This is crazy. So okay, but then also where are the checkpoints? Oh, I said checkpoint every 200, right? I said. $200. Is it going to say something? So in our config, it's 200. I want to see 200. There we go. That's fine. I hate whisper flows pop-ups. You can't close them for whatever reason. Config is we have training. There's eval every 200. Log every 50. Reserved. Oh, that's an eval interval. That's not the checkpoint interval. Oh. So I'm not expecting 10 checkpoints. That's unfortunate. Okay. Are we going to sit and watch this? It should overfit. We're going to 0. How do I say? A million parameter model on CPU. Really? Let's see. Hello. Is the I'm asking if the code's complete. if I'm able to see loss, we have a few things going on. There's hopefully there's a build status. Interesting. So how do I say it? It's like, yeah, it can delete it and then it can add a README for me on what to expect. I'm just realizing it's like, okay, how long was that where I wasn't talking? Okay, let's see. Back to okay. I feel like that's this is something we can watch in like a reasonable amount of time. Loss is going down, learning rate is decreasing. That's what a learning rate scheduler does. A million parameters is insane. I'm actually quite shocked at that. Okay, let's see. So the README checkpoints. Okay, so in a magical world, it finished. Ooh, loss. Step. What? It was running in the background. Wait. No. I'm not sure. It's like, when do checkpoints get written? If checkpoints get written after a complete run, this is our loss curve. Perfect. Okay, we finished. We did a complete training run. So let's see. We get rid of this. How do I escape this? I don't need this anymore. We interrupt it. Yes. And we'll do clear. And then, so our README, we have a model. We train. It might be the overfit run. I'm not sure. I feel like it's the actual over. Talk to it. Python generate. This would be sensational. Oh wait. I'd be so excited. Tuning. I don't know what we're talking about tuning for. Oh, guys. I am. Wait, okay. Wait. Why did I? Oh, we didn't do anything for ending a sequence. I am. Wait. Groot. I am Groot. We? Was Groot? I am Groot. We are Groot. Let's see. Am. You know what? If you, how do I say it? Yeah, it's distinguishing between lowercase and uppercase. It's like, I am Groot, am Groot. I am Groot, I am Groot, I am Groot. Groot is Groot is. Groot is Groot. Groot, we are Groot. I am Groot. We are Groot. I am Groot. Groot, Groot, Groot. Okay. Um. So let's see. Okay. I think that's sufficient for today. It's like okay. Complete run. What happened? My phone didn't die, did it? Oh my goodness, my phone died. You guys aren't going to see me for a little bit. That's crazy. Oh, that's kind of awkward. That's very unfortunate. Today's video was good. I was very happy. Um, so it's very important right now that I keep talking. So let's see. So you can check right now. Is I'm sort of writing this message to Vol Chat. Is what's it called? So can you check right now? I'm finished, or I've do I need the diag.py file? Okay, phone's back on. Let's see. Let's do open floating window, webcam. Let's take this back. Ooh. Okay. Wait, did I even click go live? I didn't click on go live. Camera. Okay. And magically, I'll be back very soon. Stay strong. Stay strong, kids. We're back. Okay. Ooh, oops. So my phone's harder to balance on the top of my laptop now because it's plugged into a wire. So I need to be very sensitive about not opening it or not making it drop. Let's see. Yes, you did complete end-to-end run. It finished cleanly. Perfect. Do you need it? No, I read it. It's throwaway. Okay. Perfect. Diagnosis. Perfect. So we'll delete it. I don't need this anymore. You're bothering me. Ooh. Okay. Okay, we've done it. How to train, sanity checks, full train run, talk to it, what to expect, a few minutes on GPU. Model size is small, few 100,000 parameters. I saw a million. Tuning, change anything in the config, notes, device auto detected CUDA if available else. Perfect. So yeah, what's the vocab size that we ended up learning? Tokenizer. Oh, well, smaller than 10,000. So that's interesting. Yeah, this shape is like I guess we have to we have to process what's it called? Yeah, I have to process how everything comes together. But we have our data set. We know how it's made. We have the checkpoints, which is our final model. Our loss is going to go all the way down. Our configuration is just this main config for the whole run. Our data loader is going to pull things. Generate.py is this is a support thing. Model.py is the main thing. We have read, train. This is awesome. So we should check all of this out later. Yeah. Okay. So today's video was good. I had fun with that. Um, is that was a language model, and it speaks in group, and it does what we expect. So we'll call this part one, and then part two is tomorrow. We'll actually look into we'll actually look into the files. Um, Deuces.